Dear students, there is another topic that I would like to briefly shed light on, that is delta star conversion, and and I will briefly show where this conversion applies, and at times it is a very useful and handy tool. So it states that, for example, we have a delta load, and in this delta load, this is Z delta, it is a balanced load, and if we want to convert this load to our Y load, then the conversion formula was Z by Z star is actually Z delta divided by 3. So whatever the load is, for example, we have 3 plus J6, that's the load. So Z delta will be divided by 1 plus J2, and we can easily write now this as this will become your Y load, and here this ZY is equals to 1 plus J2. So delta can be converted to Y and or star, and the star of Y load can be converted to by this equation. They can be interconnected. So now look at a few typical scenarios which can occur and which can be used by delta star conversion. One of I will show you two circuits that they are very commonly used in our electrical power systems. So one of the circuit, if you look at this, and this is Y source and Y load. So we have previously seen these circuits A, B, C, positive sequence A, B, C. So these circuits, we have solved numerous types of these circuits, but this circuit can become tricky when what happens is we have a line impedance, we have a certain kind of impedance here. Now, and the voltage is given at this side. For example, they have given you VAN, or maybe even they have given you this VAB. Now we must be very careful, as there is a line impedance between the source and the load, so this voltage VAB will not be the same voltage that will be across the load. So this makes questions a little tricky. So the strategy to solve this kind of question I will briefly tell, and it is very easy. In the case of Y and Y load, what we will do, we can easily assume our per phase equivalent circuit, and this will become a normal single phase circuit. Here this is VAN, this is, for example, Z line, so this is Z line, this is ZY. Now you can calculate Z of t, that will be equals to the impedance, both impedances, and then you can calculate this current IA. Actually this will be the current, IA will actually be the current, line current and phase current is same, so we can easily calculate VAN divided by Z of t. So we can solve this, and for example, this was VAN and we have calculated IAN. We can calculate voltage across the load side. I call it VLAN, and when we have this voltage, this is phase voltage, we can multiply it by under root 3 and we can calculate the voltage at this side. So by using per phase equivalent circuit, we can easily solve this circuit. Now another circuit also which is commonly used and which might cause a little confusion for the students. It is like we have a Y source and we have a delta load. This circuit, as far as we have no line impedances A, B and C, A, B and C, as far as we have no line impedances, this circuit we have already solved. Now what happens if we have line impedance here? Then it might, and you only know the voltages at the source side, not at the load side but only at this side. So this circuits here is where we can use our delta to star conversion. So this circuit will actually become, we can apply the conversion. We have Z delta here. So when we apply the conversion, it will become okay, source is like this. We still have our line impedances, but this delta load will be converted into star load, making our life easier. And the value of each of this load will be Z delta by 3, Z delta by 3, Z delta by 3, and here it will be like this: A, B and C, A, B and C. It will be connected like this. Now when we have reduced our circuit to this value, then like the previous example, what we can do is this will become per phase equivalent circuit and we can easily calculate and this will, like similar to this, we can calculate this per phase equivalent circuit. We can calculate the voltage here, we can calculate the line voltages here, and we can calculate the currents here. So this is another way in which Y delta load can be converted into a YY load and we can solve this. So in reality, when you will be doing the numericals, you only have to now correctly do the mathematics. Rest the theory is in front of you. Okay, best of luck.